The floor is lava! Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first. While you're watching this video, pieces of continents are slowly breaking off from below and are pulled down into the oceanic mantle, a hot, mostly solid layer that moves slowly under the seafloor. As soon as these fragments reach the mantle, they can trigger volcanic eruptions in parts of the ocean where there are no volcanoes. Plus, when continents break apart, it happens not only at the surface, but also deep down. But more on that later. This process can continue for tens of millions of years. The new study shows that Earth's insides are even more dynamic than we thought. It also explains why many volcanic islands, including Christmas Island in the Northeast Indian Ocean, contain unusually high levels of certain chemical elements. The thing is, these elements are normally only found in continental crust. Well, scientists did suspect that these elements showed up because some powerful forces deep inside the Earth took old, recycled pieces of rock and mixed them into the mantle. This process works a bit like when you mix together ingredients for cake batter. But before, researchers believed those elements came from two main sources: sediment that sank into the mantle as oceanic plates got pushed down, or from mantle plumes. Those are columns of hot rock rising up from deep inside Earth. However, these explanations don't fit all observations. In some volcanic areas, there's almost no sign that the crust has been recycled. In other places, the mantle seems to cool and too close to the surface to be affected by the rising hot rock. Scientists used to wonder how this could happen. Now we know that some of the material in those regions comes from pieces of continents that sink deep into the mantle, and these pieces affect the volcanoes that form above. The new study also suggests a curious idea. Continents don't just break apart at the surface, they peel away from below too. And this can happen over much greater distances than scientists thought before. Researchers used simulations to figure out how continents and the mantle behaved when stretched by tectonic forces. Their work is built on earlier research showing that when continents split, deep, powerful forces inside our planet create a mantle wave. This wave moves along the base of the continent at depths of about 90 to 125 miles. The wave moves extremely slowly, about a millionth of the speed of a snail, and gradually strips material from the roots of the continents. These peeled-off fragments are then carried sideways, sometimes more than 620 miles, into the oceanic mantle. Once there, they can trigger volcanic eruptions in the ocean for tens of millions of years. The research also shows that the mantle continues to feel effects of continental breakup long after the continents themselves have separated. Even after a new ocean basin forms, the mantle keeps moving, reorganizing and transporting enriched material far from where it originally came. To make this conclusion, researchers studied geochemical data from different parts of the Earth, including the Indian Ocean Seamount Province. That's a chain of volcanic formations that appeared after the supercontinent Gondwana had broken apart over 100 million years ago. Their computer models and chemical tests showed that right after the supercontinent Gondwana broke apart, a lot of magma with unusual chemicals pushed up to the surface. Over millions of years, this chemical signature slowly faded as less material came up from under the continent. The most unexpected discovery is that this happened without any help from those deep, hot columns of rock scientists used to think were needed. Now, to get an even clearer picture, let's sneak a peek into our planet's insides. Earth is about 4.6 billion years old. It was born from a huge cloud of dust and gas that slowly cooled, shrank, and hardened into the planet we know today. As it cooled, heavy metals like iron and nickel sank to the center, and lighter, rocky materials floated upward. This created the Earth's layered structure, with each layer having its own unique properties. The crust is like Earth's skin. It's our planet's outermost layer, made of solid rock. It's broken into huge pieces called tectonic plates that slowly drift over time. There are two kinds of crust: oceanic crust and continental crust. The oceanic crust is about 4 to 6 miles thick. It's covered with a thin layer of sediments like sand, clay, and shells. Below that are dense rocks like basalt, rich in magnesium. As for the continental crust, it's thicker than oceanic crust and is located under continents. It's made of lighter rocks than oceanic crust. Beneath the crust is the mantle. It makes up more than 75% of Earth's volume. The top of the mantle is pretty rigid, but deeper down it becomes soft and partially molten, which allows it to flow slowly. This flow is what moves the tectonic plates. At the center of the Earth lies the core. It's made mostly of iron and nickel and has two distinct layers, the outer core and the inner core. The outer core is a liquid layer of iron and nickel. It's insanely hot, up to 10,800 degrees Fahrenheit, as hot as the surface of the sun. The outer core also generates Earth's magnetic field, which protects us from harmful solar radiation. The inner core is solid because of the crushing pressure inside the planet. It's also made of iron and nickel. Now, the Earth's outer shell, called the lithosphere, is made up of the crust and the uppermost part of the mantle. It's broken into large pieces, called tectonic plates. There are a few super large plates and many smaller ones. 6 of the major plates are named after the continents they carry, like the North American, African, and Antarctic plates. But even those smaller plates play an important role. For example, the tiny Juan de Fuca plate is responsible for many of the volcanoes in the Pacific Northwest of the United States. The plates are moving like a jumble of old conveyor belts. They move very slowly, about 1 to 2 inches per year. But over millions of years, this movement shapes the face of our planet. Most earthquakes, volcanoes, and mountain building happen where plates meet, pull apart, or slide past each other. There are 3 main types of plate boundaries: convergent, when plates move toward each other; divergent, when plates move apart; and transform. That's when plates slide sideways past each other. When tectonic plates collide, the crust crumples and buckles, forming mountain ranges. About 55 million years ago, India crashed into Asia, slowly creating the Himalayas, the tallest mountains on Earth. The collision continues today, so the mountains are still rising. Mount Everest, the highest point on Earth, may even grow a tiny bit taller over time. At some convergent boundaries, an oceanic plate dives under a land plate in a process called subduction. The land above lifts up, forming mountains, and the sinking plate melts and triggers volcanic eruptions. This is how some mountains in the Andes of South America were formed. When 2 oceanic plates collide, one usually slides beneath the other, creating deep ocean trenches, like the Mariana Trench in the North Pacific, the deepest point on Earth. These collisions can also form underwater volcanoes that eventually rise above the ocean and turn into island chains, such as Japan. At divergent boundaries, tectonic plates move away from each other. In the oceans, magma from deep in the mantle rises to fill the gap. This creates underwater mountains and volcanoes along the seam. This process renews the ocean floor and slowly widens the ocean basins. By the way, a single mid-ocean ridge system connects all the world's oceans, making it the longest mountain range on Earth. On land, when plates pull apart, they form giant valleys, such as the Great Rift Valley in Africa. If this stretching continues over millions of years, East Africa could split off to become a new landmass. One famous example of transform boundaries is the San Andreas Fault in California. Unlike convergent or divergent boundaries, transform boundaries usually don't create mountains or oceans, but the grinding motion can cause powerful earthquakes, such as the 1906 earthquake that destroyed much of San Francisco.
You're standing on a beach in Hawaii, warm breeze on your face, toes in the sand, a volcano smoldering in the distance. But this fairy tale won't last long, as the whole island is sinking into the ocean, 40 times faster than the scientists previously expected. Some parts of the island could be underwater by 2050. Uh-oh. To understand why it's all happening, we have to go way back in time, millions of years ago, to see where it all started, deep under the Pacific Ocean. Now, unlike most volcanoes, which usually form along the edges of tectonic plates, the Hawaiian Islands popped into existence smack in the middle of one. That's because of something geologists call a hotspot. The Earth's mantle is like a giant pot of thick, bubbling stew. In a few places, heat builds up so intensely that molten rock, magma, punches straight through the Earth's crust. It's like turning up the heat under one part of a stew pot until it boils over. That upwelling of magma is the hot spot. As magma reaches the surface, it erupts as lava. When the lava cools and hardens, it forms land. When enough of it piles up over the thousands or even millions of years, an island forms. The hotspot doesn't move and stays rooted deep in the mantle. But the Pacific Plate, the giant chunk of Earth's crust that Hawaii rides on, is always slowly drifting to the northwest. So, every few million years, a new volcano forms over the hotspot and the old one gets carried away. Thanks to all this, a chain of islands formed, each one a little older and more worn down than the last. If you look at a map, you can trace this volcanic breadcrumb trail across the Pacific. It stretches all the way from the Big Island in the southeast, which is the youngest, up through Maui, Oahu, and Kauai, and into the sea as a chain of underwater mountains called the Emperor Seamounts. The Big Island is still growing today, thanks to active volcanoes like Kilauea and Mauna Loa. The older islands, like Kauai, are eroding, shrinking, and, sadly, sinking. Oahu is going in the water at the speed of nearly 1/40th of an inch every year. That's about as thick as 10 sheets of printer paper. But certain coastal regions are sinking at 1 inch per year, and that's no joke. This is happening for a few reasons. First, as the islands move away from the hotspot, they cool down. That might sound good in summer, but cooler rock actually shrinks and becomes denser, making the whole island sit lower in the water. Erosion gradually makes the island smaller, and unless there is further volcanic activity or a drop in sea level, the island submerges below the ocean surface at some point. Second, there's the weight of the islands themselves. They're made of solid rock and lava, thousands of cubic miles of it. Over time, their own mass slowly pushes them downward into the soft underlying mantle. And third, there's human activity. The first people who settled here were Polynesian navigators around 1,000 to 1,200 years ago. These navigators used stars, waves, and bird flight patterns to guide them and reach the Hawaiian Islands after weeks at sea. By the time European explorers arrived in the late 18th century, Hawaiians had developed a rich society with chiefs, priests, artisans, farmers, and navigators. The islands were divided into districts, each managed by local leaders, and people lived in harmony with the land. And then it was time of Kamehameha the Great. He unified all the Hawaiian Islands under a single rule for the first time in 1810. The islands were developing in the following centuries, and people needed more flat land near the coast. They started piling in dirt, rocks, and rubble to cover up soggy ground and create new land where there wasn't any before. It worked for a while, and that's how they built roads, neighborhoods, and even airports at some point. But that ground is soft and squishy underneath, and now those areas are sinking much faster than the rest of the island. A new study says that in some parts of Hawaii, this combination of factors could boost the risk of flooding by over 50% by the year 2050. It could force communities to prepare for future floods 50 years sooner than they originally thought. By 2080, flooding is expected to hit Waikiki, downtown Honolulu, and even the local international airport much more often. That could cause some serious problems for everyday life. Hawaii's tourism, beachfront buildings, and natural ecosystems could all be in complete chaos. Over $12.9 billion worth of infrastructure on Oahu alone is in danger from flooding and related damage. That's roads, hotels, homes, and way more. The scientists behind the study are hoping their work can actually help. They want local leaders to use this new data to make smart decisions that reduce future damage and keep people safe. It could help them figure out how bad flooding might get, how strong the buildings and roads need to be, and how to design communities that can survive big changes. Now, Hawaii isn't the only place in the world that's sinking because of its own weight. The weight of all the buildings in New York City is literally pressing it down into the earth. That's more than 1.68 trillion pounds of skyscrapers, apartments, towers, and bridges. That's enough pressure to make the land beneath the city sink by up to 0.08 of an inch per year. Now that may not sound like much, but it adds up quickly and in some spots. the sinking is happening even faster. Scientists call this slow downward shift subsidence. To figure all this out, researchers use satellite data to look at just how heavy the city is and how fast the ground is moving. Turns out, it's not just the buildings sitting on solid rock. Some parts of the city were built on squishy stuff like old wetlands, soft sediments, or human-made fill, the same as in Hawaii. But even areas built on sturdier ground aren't safe. The study found that layers rich with clay deep underground can keep compressing slowly over time under the weight of heavy buildings. This process is called secondary settlement and can keep happening for decades or even centuries. So even if it looks like everything's fine on the surface, the ground could still be giving way underneath. The scientists behind the research say this isn't just a New York problem. Cities around the world are expanding fast, and most of that growth is happening along coastlines. Jakarta, the capital of Indonesia, is one of the fastest sinking cities in the world, and it has around 10.5 million people living there and about 30 million in the greater metro area. Experts say that by 2030, some parts of the city could be flooded so often or so badly that all these people just won't be able to live there anymore. Jakarta was built on swampy land. It's right next to the Java Sea and has 13 rivers running through it, so flooding has always been a part of life there, but it's gotten worse lately. Scientists say that by 2050, about 95% of North Jakarta could be underwater, and it's already happening. In the last 10 years, North Jakarta sank by over 8 feet, and in some places, it's still sinking up to 10 inches every year. That's more than double what other big coastal cities are experiencing. On average, Jakarta sinks between 1/3 of an inch to 6 inches each year, and now nearly half of the city is already sitting below sea level. So Indonesia found an original solution to this problem and decided to build a brand new city in the jungle to replace Jakarta. They plan to grow Nusantara, the new capital, into a modern, green, and high-tech city in the next 20 years. City planners are calling Nusantara a sponge city, as it should be able to absorb rainwater into the ground like a sponge, instead of letting it flood the streets. That way, even with heavy rain, Nusantara won't flood the way Jakarta has. Now at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot, even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore. But when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangaea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So, people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangaea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo Pangea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat.
A sinkhole suddenly appeared in northern Siberia. This 115-foot deep hole popped up after some weird explosion that threw dirt and rocks almost 395 feet away. Since then, 2 more mystery holes have shown up in the area. People first thought it might be connected to digging for fossil fuels, since it's not far from the biggest gas field. But the search team's radar scan suggested it was probably a natural thing. The first research trip wasn't too successful because scientists couldn't get inside and take samples until the hole's sides and the water at the bottom froze. Scientists have been wondering about what caused these holes, and the ideas varied from space rocks hitting the ground to rising temperatures on Earth. One researcher suggested that the eruption had occurred due to the accumulation of pressure. A temperature decrease is often accompanied by alterations in the volume of specific chambers. These chambers contain methane. Such craters are specific to the Arctic region. Few other areas share these particular features. They all have table-like ground ice situated close to the surface, continuous permafrost saturated with methane, and unfrozen ground. Speaking of gases, a geologist suggested that the sinkhole might have been caused by gas hydrates. These gas hydrates are also thought to be responsible for mysterious happenings in the Bermuda Triangle. The Yamal Peninsula, similar to the Bermuda Triangle, has been a place known for unexplained events. Here, residents even claim to have seen the abominable snowman. Sinkholes can pop up out of nowhere. Some are massive enough to gobble up whole buildings. They happen when rock under the ground, like limestone, starts getting dissolved by the water it contains. As the rock melts away, these big holes, or caverns, start forming. When these caverns become too much for the land above to handle, bam! The surface caves in. Ice is melting like crazy. The Arctic is warming up way faster than the rest of the world, so ice sheets and glaciers are shrinking. As these chunks of ice melt, they pour fresh water into the oceans, raising sea levels and making Earth's crust sink. During the last ice age, those massive ice sheets pushed down on Earth's crust, making it bend and sink. When the ice started melting, the crust began to bounce back. But now, the ice is melting too fast for the crust to keep up. This sinking situation creates a dangerous loop. As land goes down, more seawater creeps in, causing more erosion and flooding. What about other parts of the world, such as China? It hosts the deepest and largest sinkhole on the planet. This sinkhole is 2,165 feet deep and holds a crazy amount of space. 130 million cubic meters to be exact. They call it the Heavenly Pit, and it's not just big, it has its own mini ecosystem. 1,285 different plant and animal species can be found there. There's an ancient forest and a thick jungle of plants in there. This formation is a double-nested sinkhole with two craters connected by a sloping edge. When it rains, a waterfall shows up at the mouth. It feeds an underground river and cave network. When you look down from space, you'll see these deep, dark marks on the green landscape, like a footprint. Some suggested that these formations could have been left by a meteorite smashing into Earth. Others said it had taken about 128,000 years for water to carve them out. It could have snuck into underground rivers and worn away the limestone rock. It turns out, locals have known about this place for ages, but the rest of the world only caught wind of it in 1994. British explorers tried to map out its underground cave system, but it's like a maze down there. After 5 tries in a 10-year span, the team couldn't handle the rushing river and had to throw in the towel. So, this deep, mysterious underworld remains one of China's biggest geological puzzles. The next one is Crveno Jezero in Croatia. This is a huge, mysterious pit. It's not like a regular lake. It's basically a giant hole that formed when the ground collapsed into what was once a massive cave. The walls are super steep and have this reddish tint because of iron in the soil, which makes it look pretty wild. Inside, there's a deep blue lake that's incredibly clear, but also super cold. What's really cool is that it houses a unique species of fish that's only found there. Plus, the water level goes up and down because of an underground stream. It's a bit of an adventure to explore the lake because it's surrounded by sheer cliffs that can drop rocks without warning. Let's shift our gaze to Venezuela's Cima Humboldt. This is a colossal sinkhole hanging out in a flat-topped mountain. This beast of a hole plunges down 1,030 feet. You can find an entire forest at its base. It's home to many plants and animals that only live there, like a unique frog called Stephania rhei. In 1974, people went on an exciting trip there for the first time, and they had to cut down trees so that helicopters could come and pick them up, kind of like something you'd see in an Indiana Jones movie. The second largest blue hole on the planet, known as Tamya, which translates to deep water in Mayan, is in Mexico, and that's where we're going. This underwater marvel was uncovered off the shores of Mexico's Yucatan Peninsula in 2021. But the deets about this sinkhole have just surfaced recently. It's 900 feet deep, with the sides so steep they're almost 80 degrees. The entrance to this cavern is about 15 feet below sea level. Blue holes like Tamya are these natural wonders formed during the ice ages. When the sea level was way lower, rain and other natural elements eroded limestone, creating these deep, vertical shafts. Then, as the oceans filled back up, these holes got submerged, turning into the mysterious blue holes we see today. They're called blue because the deep parts are darker than the shallower waters around them, making them look striking from above. Despite being low in oxygen, which usually makes it tough for sea life to thrive, blue holes are bustling with unique forms of life, especially bacteria. They're also gold mines for scientists because they can preserve ancient fossils in conditions you wouldn't normally find elsewhere. The team that discovered Tamya used scuba gear, sonar equipment, and water sample testing to map out the blue hole and study its water chemistry. They found that it was not just deep, but also massive, covering a surface area of 147,357 square feet at its widest point. This discovery was made partly thanks to local fishers who had been whispering about its existence. Now, scientists are diving deep into its secrets, hoping to learn more about the unique ecosystems that blue holes can host, and how they might give us clues about handling climate change and preserving marine life. Another spot is Dean's Blue Hole, This one is just off Long Island in the Bahamas. This underwater wonder goes deep, reaching 663 feet. The massive blue hole is surrounded by rocks, a lagoon, and a pristine white beach. Dean's Blue Hole isn't just a pretty sight, it's a hotspot for freediving enthusiasts. People come from all over the world to take the plunge into its crystal clear depths. There are multiple passages branching off from the main blue hole, leading into intricate cave systems and mysterious underwater rooms. It stands out also because it's the second deepest blue hole in the world, falling just behind the Dragon Hole in the South China Sea. This place is a big deal in the scuba diving world, especially since a swimmer set a world record here by diving 331 feet deep on a single breath without any fins.
Is the Big Apple getting a little too heavy for its own good? A recent study revealed that New York City is sinking. And get this, it's all because of those towering skyscrapers. Apparently, the whole event is called subsidence, which is when the Earth's surface settles bit by bit, or suddenly sinks. Soft sediments shifting and the weight of the city itself are the culprits behind this sinking sensation. Now, don't get too alarmed. The study found that New York is sinking at a rate of 0.04 to 0.07 inches per year. Sure, that doesn't sound like much, but there are parts of the city that are sinking even faster than that. This sinking situation could cause some trouble for the city, especially since it's already pretty low-lying and home to over 8 million people. So it's important that local authorities come up with some strategies to tackle the growing flood risk and rising sea levels. Although, I'm not sure building giant seawalls is the way to go. We might need to get a little more creative than that. Geologists want to make sure we're all aware that building more high-rises near the coast, rivers, or lakes could contribute to future flood risks. So we really need to think twice before we start constructing skyscrapers left and right. In recent studies, scientists calculated the total mass of all the buildings in New York City, over 1 million of them, and it adds up to a whopping 1.68 trillion pounds. Talk about a heavy load. Now, they didn't include the weight of the roads, sidewalks, bridges, and other paved areas, so you can only imagine how much more weight is added to the city. But hey, even with these limitations, the researchers did a pretty good job of accounting for the complex geology beneath New York, including the sand, silt, clay deposits, and good old bedrock. They found out that certain types of soil, like clay and artificial fill, are more prone to subsidence. On the other hand, bedrock stays pretty firm and keeps those skyscrapers in place. So at least we don't have to worry about the Empire State Building taking a dive anytime soon. Comparing their fancy models with satellite data, the researchers created a map of the city showing where the sinking is happening. And guess what? The increased urbanization and all that groundwater pumping and draining are only making things worse. It's high time we start protecting our resources, don't you think? I wouldn't start packing my bags just yet. New York isn't the only sinking city out there, you know. Jakarta, the capital of Indonesia, is facing some serious sinking action too. In fact, parts of it could be underwater by 2050. That's like a real-life Atlantis situation. Over 30 million people in Jakarta are now deciding if they should relocate the entire city. If there's a city out there we should worry about sinking, that's Venice for sure. But why is it so eager to take a dive, you might ask? Well, let me tell you the complex truth. You see, Venice decided to set up shop on a marshy lagoon with shoddy foundations. As time went by, the ground underneath just couldn't hold it together and started compacting like a squished marshmallow. On top of that, the city's been slurping up groundwater like it's going out of style or something. The cherry on top of this mushy cake is that the sea levels have also been slowly rising. And guess what? Those sneaky plate tectonics are having a laugh by shoving the Adriatic plate under the Apennine Mountains, giving Venice an extra push downward. Someone had the bright idea to stop pumping groundwater, thinking they could stop the sinking shenanigans. But hold your gondolas. A new study revealed that the sinking hasn't completely stopped, just slowed down a bit. It turns out the whole area is tilting ever so slightly to the east, with Venice perched on the slightly higher end. You must be wondering how much Venice sinks in a year, right? Brace yourself for this shocking revelation. It's sinking at a rate of about 0.04 to 0.07 inches a year, similar to New York. At this pace, in the next 20 years, it could sink a whopping 3 inches below sea level. To avoid turning into a Venetian fishbowl, locals are frantically building special barriers to keep the water from crashing into the lagoon. But don't hold your breath, because this project has had more delays than you'd expect. Oh, and have you noticed that charming old-style vibe in Venice? It's not just because they're fans of the vintage look. Those salty waters have been wreaking havoc on the buildings, thanks to the water levels constantly breaching the original damp proofing. Now the water's cozying up to the masonry, and the ground floors of many apartments are no longer safe enough to live in. Now, when will Venice take a dive into the abyss? It's hard to say for sure. Subsidence and rising sea levels are as slow and unpredictable as a turtle in a marathon. But experts have playfully warned that if things continue as they are, Venice could be doing the backstroke beneath the waves by 2100. Fear not, though. They're doing their best to protect this floating gem of history and culture from becoming a Hollywood disaster flick. So don't cancel that Venice day trip just yet. New Orleans has a peculiar watery situation going on too. You see, this lively place was initially built just a smidge above sea level, and now it's gradually sinking. Back in the day, when an area of the city called the French Quarter was just popping up, folks had to make do with what they had. They scored the best land they could find, but it was only about 10 feet above sea level. And let's not forget, the rest of the city is as flat as a pancake, with the areas around the French Quarter being just a hair lower. Now, even though they knew they were up against some soggy odds, the resourceful New Orleans residents did their best to elevate their houses above the flood-prone land they chose as their home. There's more. The ground beneath New Orleans is as wobbly as a plate of Jell-O. Architects had to keep things short and sweet because they feared the soil couldn't handle the weight of taller structures. They played it safe, sticking to 2 or 2.5 stories. Here's where it gets interesting. The city installed a fancy drainage system in the 1900s, thinking it would solve their water woes. And while it did help with the marshes and all, it inadvertently sucked the life out of the soil. Yep, the ground was left high and dry, without enough sediment and water to keep it steady. As a result, those former marshes sank as if they were in a quicksand competition. By the 1930s, things got even more topsy-turvy. 1/3 of the city was below sea level, and by the time Hurricane Katrina made its grand entrance, that number skyrocketed to around 50%. Oh, and here's the icing on the cake. Sea levels decided to join the party, rising faster than a helium balloon. So now, not only is New Orleans sinking, but the surrounding area is also at various degrees below sea level. So what can we do about all these sinking cities? Well, for instance, we could manage our water consumption a bit better. We can't just keep sucking groundwater out of the earth like there's no tomorrow. We've got to find new ways to quench our urban centers' thirst. Think about it. We could purify surface waters, or even turn salty seawater into a sweet solution. Of course, we'll need a boatload of energy to make it all work. Speaking of great urban water management, Let me tell you about a town in Denmark called Nye. These guys have got it all figured out. They collect rainwater and use it to supply their toilets and washing machines. Talk about resourcefulness. Now that's what I call a splash of genius. Mexico City is one of the biggest cities in the world, with a population of about 22 million. This is a megapolis filled with cars, crowds of people, skyscrapers, beautiful buildings, and other attributes of big cities. That's why it's hard to believe that, right now, the city is slowly sinking into the ground. Mexico City was founded by the Aztec Indians in the early 14th century. At that time, it had a different name. The Aztec capital was surrounded by a large lake. Much later, the city was renamed Mexico City and turned into a huge metropolis. For centuries, people have been pumping water out of the area, but it doesn't help much. By the 19th century, people realized that some parts of the city were slowly sinking because of wet clay. At that time, it was happening so slowly that no one worried about it. But recent studies have shown that the process is accelerating. It's impossible to predict at what rate the city is going down, since it's built on a mixture of clay and volcanic soil. Because of this, the city sinks unevenly. In one area, several buildings can go underground in a matter of days. In another district, houses can stand for centuries without change. Soil collapse in particular streets can trigger a chain of earthquakes and landslides. Huge modern houses are at great risk. They're heavy and stand on wet clay that has never hardened. As a result, the clay falls deeper and deeper under the weight of such buildings, dragging along entire city sections. Some researchers are sure that the city could sink 65 feet in the next 150 years. This means that all 6-story buildings might end up underground. Skyscrapers will eventually sink too, and 1-story villas will disappear much earlier. Some densely populated areas in Mexico City are sinking by 20 inches per year. That is, every 3 to 4 years, each building goes down by the height of the average person. Outside the city, some places are built on even wetter soil. In 150 years, 10-story buildings will go underground there. People in Mexico City have invented a unique system for pumping and processing water. Unfortunately, there's no guarantee that this will help to prevent the city from sinking. Water has been in this soil for thousands of years. It's almost impossible to make the earth solid. One of the most reliable ways to save the city is to strengthen its foundation. This task will require a huge amount of concrete. But even this artificial hardening of the soil may not help. There's too much moisture deep underground, and all that concrete can simply sink even lower. This next town is also surrounded by water, but that's not because it's sinking. Small Geethorn is located in the Netherlands. This place has tons of canals. We can say this is Dutch Venice. There are so many river channels here that there are no roads at all. You can step out of your house and get to the bank of some stream or river in no time. People here travel by boats instead of cars. This is one of the main features of the town. You won't hear beeps or sirens. Locals claim that you won't actually hear anything louder than bird songs. And unlike on regular roads, there are no traffic jams in the canals. But even if the town didn't have its amazing water routes, it'd still be lovely. Beautiful cozy houses, small bridges, lots of plants, colorful flowers, and trees. Then there's the island of Burano in the Venetian lagoon. It's filled with canals just like Venice, but this place has one difference. In the past, thick fog regularly descended on the city. It made visibility very low, and the residents of the place often confused their own homes with others. The buildings were too similar to one another in architecture. That's why locals decided to paint their houses in bright colors to recognize them even in thick fog. According to this legend, that's why all the buildings in Burano are painted in different colors. You can see bright pink, yellow, green, turquoise, and other hues here. Every 2 years, locals renew the paint to maintain the beauty of the city. If you buy a house here, you will have to get a special permit for painting it, and the color will be chosen according to a special system developed many centuries ago. Our next town is one of the most unusual in the world. You're in cold Alaska, heading to Whittier. A long tunnel is the only entrance to this place. As soon as you go through it, you find yourself in a strange place. It's very cold here. Strong winds are blowing, and it's snowing heavily. The streets are empty. You don't see any locals. It seems the town is abandoned, but then you notice a wide 14-story building. You go inside and see all the residents are there. Whittier's population is about 220 people, and they all live in one building. In addition to residential apartments, inside you can find stores, a police station, a library, and a cafe. Imagine going to your office a couple of floors beneath your home, and the store is just next door. There's a post office on the first floor, next to the entrance. But the coolest thing is the view from the windows. You can see the incredible beauty of the snow-covered mountains. You aren't likely to notice the next small town if you don't know what you're looking for. Everything, houses, cafes, a post office, and other buildings, is all underground. You can only see pipes pouring out smoke protruding from the ground. Welcome to Coober Pedy, Australia. In addition to the pipes, there are warning signs everywhere. They inform you about inconspicuous holes you can fall into. Go inside, and around you, you'll see soil instead of the regular walls and wallpaper. But this isn't the only unique feature of this place. Most of the opals you can buy from all over the world are mined in this city. In 1915, opals were first found in the soil there. Since then, people have been coming here to search for these precious stones. There are no mining companies here because you can't determine the presence of opals by exploratory drilling. To find an opal, you simply need to dig and look around. People come here, rent some land, and build houses right in the ground. Let's finish our journey not in a city, but in the village of Kuldara in India. It's not easy to get there. It's not a really hard-to-reach place, but not every local will agree to drive you there. You may have to pay twice the price to the driver. And even in this case, they won't bring you exactly to the place. They'll stop nearby and tell you how to get to your destination. Kuldara village is abandoned. There are only ruins and old buildings. This place looks like an ancient city that has been recently excavated from the ground by archaeologists. The first buildings here were constructed around the 13th century. The city consisted of many small villages that were united into communities. Locals were engaged in agriculture. Also, there were valuable gypsum rocks and minerals in this region. The place flourished for several centuries in the past. But in 1825, everything changed. One night, the residents quickly got their stuff and left their homes. Overnight, Kuldara became abandoned. The most interesting thing is that no one knows why it happened. According to one theory, the village's water reserves decreased. But it doesn't seem likely that this could force the residents to flee their homes in the middle of the night. The most popular version says the local ruler collected huge taxes from this small place. Then, he fell in love with the village chief's daughter. The ruler threatened he would start collecting even more taxes if the girl refused to marry him. He gave her 1 day to make the decision. The locals decided to support the girl and her father, so they left their homes in one night. Many people think this village hides a mystery. It attracts many tourists. They believe the residents of the village had cursed this place before they left, so that no one could live there. The locals are afraid of this area, and so they try to avoid it.
Oh look, there's a giant blob heading straight for New York City. Oh wait, hold on. You'll actually have to look down, not up. Because this blob is a mass of hot rock moving beneath the Earth's surface. And when it finally reaches the Big Apple, some say it could tear the continent in two. But Yankees fans, and even you Mets fans, don't worry, this journey is going to take about 15 million years or so. You see, a long time ago, people noticed something curious. When they looked at world maps, they thought, don't the continents look like puzzle pieces that could fit together? That couldn't just be a coincidence, right? Then, in the year 1912, a German meteorologist named Alfred Wegener came up with a revolutionary idea, something we now know as the theory of continental drift. Wegener said the continents are always on the move, and those huge chunks of land we see today were all once connected, forming one giant supercontinent called Pangaea. That idea suddenly explained a lot of mysteries, like why fossils from the same species turn up in different corners of the world, even though entire oceans lie between them, or why coastlines of continents match up so neatly, just like South America and Africa. Wegener also explained that mountains form when a drifting continent runs into another one, crumpling the land and pushing it upward. That is exactly how the Himalayas came to be. The Indian plate collided with the Eurasian plate, and the land rose into the massive mountain range we see today. Now these days, everybody learns about Wegener's idea in school and takes it as fact. But back then, many people thought he was completely out of his mind. I mean, whole continents moving around? What on earth could push them? That's why it took scientists more than 50 years to finally go, oh, I see, it's the Earth's mantle. Yep, slow-moving currents of hot rock deep in the Earth's mantle push the tectonic plates around, and that means the continents move too. Picture super tough puzzle pieces floating on top of boiling oatmeal. That's a picture. Yep, they drift, and sooner or later they crash into each other. This is what happens on Earth's surface. And that's how we finally agreed that Wegener was right. But what if I told you that might not always be the case? Some experts agree that the supercontinent Pangaea started breaking apart about 200 million years ago. And that's how we ended up with the world map we know today. But a recent study is challenging part of that idea. And it all comes down to a giant mass of hot rock, something scientists call the Northern Appalachian Anomaly, or just NAA. Yep, what we casually call a blob, the experts call an anomaly, and that is simply because it is hotter than the rock around it. So this anomaly sits about 124 miles beneath the mountains of New England and stretches up to 249 miles wide. It lies in the asthenosphere, the semi-molten layer of Earth's upper mantle. But here's the strange part. It should not even be there. I mean, rock formations like this normally don't exist in that part of Earth's interior. For years, scientists thought the anomaly was left over from when the North American continent broke apart from Northwest Africa about 180 million years ago. This new study says that might not be the case. It suggests the blob is actually linked to the process that split Greenland from North America only about 80 million years ago. The idea then is that this blob is a leftover from when the landmass broke apart, a piece that never quite settled down. This is one stubborn blob we're talking about because it is still on the move, super slowly. But still, it moves only about 12 miles in a million years. Over time, it's already traveled more than 1,100 miles from where it first appeared. And now, New Yorkers, watch out! This blob of scorching hot rock is heading your way. Okay, I know, I'm being a little dramatic. The truth is, we really don't have to worry. First, scientists say it won't even get near the city for at least 15 million years. And second, even though we call it a blob, it is not something gelatinous. It is not oozing. And it is definitely not going to push its way up through the Earth's crust and invade the New York subway, or anything like that. That is just not going to happen. What the anomaly will look like, or what it might do to the continent in the future, is still a mystery for geologists. But they are pretty confident it will not have any real impact on human infrastructure or on our daily lives. It is not like lava that's suddenly going to burst through the floor of your house. That's because, at the end of the day, the blob is just rock. Like any rock you see on the street, only super high, enormous, and buried deep inside the Earth. To explain why this rock is sitting in such a weird spot, scientists came up with what they call the mantle wave theory. So think of it kind of like a lava lamp. After continents break apart, hot, heavy rock can detach from the bottom of the tectonic plates in blobs. These blobs, or pieces of rock, move around under the crust and create waves. When that hot material slips under a continent, it works like the flame under a hot air balloon. It gives the land a little lift. Then, when continents stretch and split, space opens up underneath and semi-molten rock quickly fills in. Eventually, it cools down, gets heavier, and sinks. Meanwhile, hotter mantle material rises up and creates a warm patch called a thermal anomaly. This sudden motion shakes up the base of the continent. Imagine a row of dominoes. One piece falls and the rest follows. Blobs of rock start dripping downward one after another, and over time, they slowly move inland. Scientists think these rock currents keep flowing, rippling under the surface for millions of years. Now, knowing all this matters because the anomaly might have played a role in shaping the land above it. For example, it may have lifted up some ancient mountains over the past few million years. That helps to explain a big mystery of the region: why the Appalachians are still standing. I mean, why haven't they worn down as much as you would expect after all this time? Well, think about it. The Appalachians are ancient. This mountain range in North America started forming hundreds of millions of years ago, long before the dinosaurs. With all that time, rain, wind, and erosion should have worn them down to almost nothing by now. Honestly, some geologists expected them to be rolling hills at best. But nope, they're still mountains, pretty ones too, and much bigger than they should be. And here's where the blob comes in. See, when a giant pocket of superhot rock sits under a mountain range, it can actually give the crust a little lift. It's kind of like putting a balloon under a blanket. The blanket rises up. The heat makes the Earth's crust lighter. So even while wind and rain are wearing the mountains down from above, the Earth is gently pushing them back up from below. There is another positive takeaway from this study. These new insights can help scientists better understand other strange geological features around the world. In fact, the researchers believe they may have already found a twin to this blob, sitting under north-central Greenland and also tied to the Labrador Sea. So, what can we conclude from all this? Well, tectonic plate movement is still the reasons continents break apart. But the process goes much deeper than we thought. The effects of ancient rifting can still play out millions of years after the surface split, just like what happened in Greenland. Although it's still really hard to predict what this anomaly will look like in the future, we know one thing for sure right now: there is nothing to fear, and I'm betting that most of us won't be around for that. Ring ring, your mail's here. You ordered it yesterday all the way from across the country, but it only took a day and a half for it to reach you. It's certainly not like the 1800s when your mail would get delivered by horse. The entire process back then would take up to 10 days, and it's not like it came from another continent. Frontiersmen were your postal service. They'd hop on their horses and ride the distance. Considering how far away it was, and it could be thousands and thousands of miles, they did this in a surprisingly short amount of time. Gears have shifted though. We've come to the 1900s, and you're a pilot now. You're en route and it's getting dark, but you're still thousands of feet up in the air. Maybe it's time for you to land since you can't see a thing. Plus, you're starting to run low on fuel. If you were to have an emergency landing right now, things might get iffy down there. You'd be in a strange territory, and you won't know what weird things you might be up against. Some of your coworkers tried, and it wasn't a very good idea. Look out for that shadow. Even if you did want to fly at night without much visibility whatsoever, it wouldn't be a good idea. See, you're guided by landmarks when charting your route. That mountain ahead looks familiar, but the closer you get to it, the more you realize you've made a mistake. It's not like the weather will play nice either. So you stop, and the letters you were carrying will now go on a train where they can ride out for the rest of the night. After dawn, it's time for another pilot to take them up to the sky again to speed up the process. This whole ordeal takes a lot longer than it should just for mail to get across the country, and people are already waiting at their doorstep with their arms crossed and grumpy faces. Radars are nowhere to be seen yet, so great minds got to thinking, what if we change things with some big arrows on the ground? This way, pilots would always know where to go. On top of these, towers would serve as beacons of light. Now pilots would be able to navigate at night, and you wouldn't need to rely on sketchy mountains to know where you're at. The arrows went all the way from New York to San Francisco, and there were approximately 1,500 of them. Towers were 50 feet tall, and their lights would rotate while flashing every 10 seconds. The arrows themselves were pretty huge too, about 50 to 70 feet long. They were painted bright yellow so you wouldn't miss them. Every 3 to 5 miles, you'd spot one of these arrow beacons. When the weather was nice, you'd be able to see the lights coming from the beacons from as far as 10 miles away. And below those, there was another set of lights. Red and green lights would flash a Morse code, and pilots would know exactly what beacon this was. The worst has happened, and one of your engines is failing. You're prepared for this, and up ahead, there's a landing field placed there exactly for this type of situation. Every 25 miles along the aero route, you'd find one of these intermediate landing fields with rotating radiant lights on them. Even though less common, these would be more powerful than the other type. You could see them from as far as 75 miles away. But technology kept improving, and it got to the point that the regular beacon lights got so strong they'd be seen up to 40 miles away in clear weather. Because of this, they only needed one tower every 10 miles. Then, the four-course radio stations came along, and all a pilot needed was a radio receiver, a pair of headphones, and a chart. Arrows became a thing of the past. On the plane, a pilot would listen to audio signals to check if they were on track. And soon, the radio was all there was. You'd have it all: guidance, weather info, and even radio beacon signals. With Morse code communication, pilots would turn to the right when hearing a certain stream of code, and to the left if they heard a different one. A steady tone would mean they could just fly straight ahead. Sometimes, though, mountains would bounce off radio signals, and it would lead pilots into a completely different course. This, of course, would end up with a plane being stranded somewhere. LORAN, that's long-range navigation, coordinated the pilot's location better. These stations were placed all across the Atlantic and the Pacific. Two different stations placed far away from each other would emit a signal at the exact same time. And with the help of two others, also emitting signals, you'd be able to figure out the location of a plane. It's a four-station work. LORAN had a big weakness: electrical storms. Put simply, if a plane was in the middle of a storm, it would be like it never existed. The last aero beacon was only shut down in 1973. It lasted a long time. But today, you'll still be able to see some of the arrows from back then. They aren't painted bright yellow anymore, they're just big, plain, concrete arrows. Most of them were lost while redeveloping some of the cities over the United States. There's one west of Phoenix, Arizona. It was the beacon number 33 of the LA to Phoenix Airway. The arrow is gone, but part of the radio tower is still there, although in bad condition. There are about 10 of them in California, and the rest are spread around the country. But let's jump a few years back before the arrows and radio. Around 1910, when pilots would only fly using pilotage, they'd chart their route based on landmarks. They would only dare flying during the day and not at a high altitude. In the 1920s, though, they started venturing into flying at night and even further than they were used to. But since landmarks were nearly impossible to identify at night, they started using celestial navigation. They tried to read the stars to know where they were. They had the help of some tools, but it wasn't too effective because they would still get lost more often than not. Turbulence wouldn't help either, because instead of reading one star, they'd look at a completely different one, the wrong one. With no light pollution and way too many stars to count, it was too easy to get lost in the sky. A plane stays aloft because its wings are shaped so that air moves faster over the top of the wing, and because the air is moving faster, its pressure decreases. It means there's less pressure on top of the wing than on its bottom. It's this difference that lifts the wings and the plane up. Rolling the plane is the aileron's job. You lower the aileron on the wing you want to rise, and you raise the aileron on the wing you want to drop. The pitch is what makes a plane go up and down when the elevators on the plane's tail are adjusted by the pilot. Lowering them will make the plane's nose drop, and raising them will make it rise. The yaw is what makes the plane turn. It's the rudder's job. When it is turned to one side, it'll move either left or right. The nose of the plane will always be pointed in the same direction as the rudder. Next time you're on a commercial flight, you can track the plane's movement yourself and know what the pilot's doing. Not entirely, though, because there are tons of complicated mechanics and systems at work in that cabin in front of you. And if you want to know how that works, it might be time for you to enroll in a flight academy. Maybe one day you'll fly fast enough to break the sound barrier. Pilots that do this literally break the sound waves that form in front and around the plane. Air will gather and compress in front of the plane. This will form a shock wave that the plane needs to go through, and when it does, it makes a really loud noise, a sonic boom. It's because of the sudden change in the air pressure. The Concorde was a commercial plane that was way too expensive for an average person. It not only broke through the sound barrier, but could travel up to 5 times the speed of sound.